Take a bow. We are done parsing HTML. That was it. We've seen all of the relevant rules. Well, I haven't actually shown you the detail for handling tag arguments, but we'll get a chance to look into that later. For now, let's go on to JavaScript, which is actually going to have very similar rules to HTML. You may have already guessed that a lot of the options in JavaScript are very similar. We have a large number of binary operators, plus, minus, times, divide, less than, greater than. And it turns out that there's a very convenient notation when we're programming grammars for getting those all in. Rather than having to make a separate little parsing function or parsing rule for each one, I can just write out multiple related parsing rules in the same string and give one piece of code that applies uniformly to all of them. So we said before that this colon kind of meant the arrow. This vertical bar, it's as if we had written this same non-terminal exp one more time and then another arrow. Expression goes to expression times expression. This is just a concise notation for your benefit. It's so that we don't have to type out as much. And here I'm showing how to make a abstract syntax tree, which again for us is just nested tuples, for a JavaScript binary operator. And in reality, we'd want to add in another rule for divide, less than, greater than. We might have 10 of these at the end of the day. But it turns out that our old friend ambiguity is going to rear its head. If my input is 1 minus 3 minus 5, there are actually two ways we might interpret that, or two parse trees we might end up with. And depending on which one we pick, we get a slightly different answer. This could mean 1 minus 3 minus 5, at which point we'll get negative 7. Or it could mean 1 minus 3 minus 5, at which point we'll get 3. We say that this first option is what is known as left associative because it puts the parentheses on the left, or the tree ends up being sort of unbalanced towards the left. Similarly, this second option is right associative.